Good morning students. In today's class we are going to study about types of DC machine. What do you mean by DC machine? A machine means it can be a generator or a motor. Today we are going to study about types of DC machine. So mainly types according to field winding they are mainly divided into two types. One is separately excited DC machine, then another one is self excited DC machine. These are the two broad classification of types of DC machine. In separately excited, the field winding or the supply to the field winding is given by an external DC source. That's why it is called as separately excited DC generator. But in case of self excited DC generator, the excitation is from the machine itself. That means machine is providing excitation to its field winding. That's why it is known as self excited DC machine. Again, self excited DC machine can be classified as three types. First one is shunt DC generator, then series DC generator, then compound DC generator. Then compound can also be divided into two types. One is both long shunt and another one is short shunt. So self excited machine can be divided into three types, that is shunt, series and compound. And compound can again be divided into two types, that is long shunt and short shunt. Now we are going to see each of the classification separately. So we will start with separately excited DC machine. We will see separately excited DC machine. This is a diagram of separately excited DC machine. Here there is no connection between armature resistance or armature and field. There is no electrical connection between an armature and a field. So to excite field, we need an extra DC source, that is known as external supply. So in separately excited DC machine, external DC supply is required to excite this field. When this field is excited, then EMF will be generated here, because this EMF depends on as we know, Eg is equal to P phi Zn by 60A. So this EMF depends on flux. If flux happens, then EMF will also happen and current will flow to the load. So to make this EMF happen, we have to create this field. To create this field, we have to provide current from an external DC source. So there is no connection between armature and field in case of separately excited DC machine. Now we will see shunt machine. Now we will see shunt generator. shunt generator. So what do you mean by shunt? Shunt means parallel. Here this is our armature, this is our armature, this is armature resistance, this is EMF generated or generated EMF. In shunt generator, the field winding is in parallel with the armature resistance. If armature and field winding are connected parallel or across each other, then it is known as shunt generator. This is shunt resistance RSH and this is load resistance RL. So when armature current flows, it flows through armature resistance and divided at this point. So some current flows through shunt resistance, that is ISH, and some current flows through load resistance, that is IL. So why it is called as shunt generator? Because the shunt field is in parallel with the armature, or the armature is in parallel with the shunt, with the field. That's why it is known as shunt generator. Next we will see series generator. Series generator. In series generator, this is armature, this is armature resistance, this is generated EMF, this is series field. This field is in series with the armature. This is load resistance. This is series field. Field is in series with armature. That's why it is known as series generator. As field is in series connection with armature, that's why it is known as series generator. Here, if current starts to flow, it will flow in a single path. That's why current will remain same in all the three elements. That means current will be same in armature as well as series field as well as load resistance. In series generator, current remains same. Current remains same. So we have studied about series generator as well as shunt generator. Now we will study about compound generator. Why it is known as compound generator? Because compound means it is a combination of both series as well as shunt. So it combines both the effect of series as well as shunt. So it has two windings. One is series, one is shunt. We will draw two diagrams simultaneously. That is, compound generator is again divided into two types as we have seen. Compound generator, one is long shunt, another is short shunt. Long shunt and short shunt. So as we know, here we have two windings. One is series, another one is shunt. Here also we have two windings. One is shunt, another one is series. This is shunt resistance, this is series resistance, this is shunt resistance, and this is series resistance. We have to connect armature in series path. Armature in series path. Then we have to take load resistance. This is armature resistance EG. This is RA, this is EG. Load is connected here, load resistance. So what is the main difference between a long shunt and short shunt? In long shunt, this shunt resistance is connected across series field. That means series field and armature combiningly is in parallel with shunt field. Combining both series as well as armature, we can say both series field and armature is in parallel with shunt resistor. But here in short shunt generator, this is only parallel with field is in only parallel with armature. Field is only parallel with armature. If shunt field is, if series field is here, series field is not in parallel with shunt resistance. Here series field is parallel with shunt resistance. So this is the major difference between a long shunt and a short shunt DC generator. So we will conclude here. Thank you.